Hi everyone, we are looking at this same problem we started earlier on, video number 1. This is now video number 2 on game theory. Video 2, DEO. We already solved section A using a movement diagram to find a solution to this static zero-sum game G. We are now looking at part B, which says using the iterated elimination dominated strategy. Is a kind of iteration process, recursive process to solve this kind of problems. I've just copied this data that is given us, put it here because we're going to do some iteration on this one here. So we have these entries. Let's start by looking at what Colin is doing on these entries. Then we'll apply the elimination dominated strategy. If you look at the columns here, you can clearly see that column C, all the entries in column C are bigger than the entries in column E. 24 here is bigger than 8, 8 is bigger than 6, 16 is bigger than 4. So according to the strategy we are using, dominated strategy, we eliminate C because column C dominates column E. So we eliminate this one. Okay? So that's our first iteration. C is gone. All the entries here are now gone. Everything here is gone. Then again, let's see at what is left, what remains here. We have column D and column E. Column E dominates column D. Each entry here is bigger than its corresponding entry. 8 is bigger than minus 6, 6 is bigger than 4, 4 is bigger than minus 4. So column E dominates column D. Therefore, column E goes. This one again goes away. That's the iteration. That is the second iteration. This one is gone. If you are solving an assignment or doing exams, you don't do it like this. You do it separate columns, separate pages. You don't just do on the same page, erase and something like this. So now let's look at what we can do with what is left for us. Can we do columns again? This and this is bigger than this. This is bigger than this. No, this can't do column. This is bigger than this, bigger than this. This can't do column. Now let's see if we can do rows. And for the rows, it's just the opposite of what we have done on the columns. We compare again, 2 rows, then the dominant, eliminate the dominant one. In this case, eliminate the smallest one, not the bigger one. The columns, you do the bigger. The rows, you do the smaller. So now if you look at row A, minus 16, minus 10, minus 6, and row B, everything in row B is bigger than what is in row A. Okay? Here you can't do it here. So row A therefore goes. So therefore A is gone. So what is left? BC and ABD. So can we do column here? Column. No, we can't do column. Yeah. This is bigger than this. This we can't do column. This is bigger than this. We can do row. Row elimination. Smaller one. We can't do row. We can't do column. 8. Yes, we can do column. Column A, 6 is bigger than 4. 8 is bigger than minus 4. So therefore, the bigger one, or the maximum, goes. So therefore, this one goes away, according to the iteration method. Yeah, when you are doing column, the bigger one goes. So this one is gone, and A is finally gone. So now left with B and D. So B and D, what do we have? Column, the bigger one goes. This is bigger than this. Yes. Column. This is bigger than this, but this is smaller than this. But for row, it's smaller and smaller. Yeah, everything here is bigger than what is here. So for row, the smaller one goes, because this row is bigger than this row. So this one goes. So now row C is gone. Row C is gone. We now have 2 columns left. Column this and this. And according to column, the bigger one is the dominant. The dominant one goes. So 8 dominates, B dominates D. Therefore, B goes. So this one goes. So again, this goes. So we now have our solution as BD, which is 4. So again, we have our solution to our problem there. D is 4. Movement diagram was 4 as well. Thank you for watching. Bye bye.